We are interpreting exponential functions and their constants in this case. All right, so the problem is giving us a function, and here's the function here, and this represents the change in quantity over t hours. Okay, what does, they're asking, here's the question, what does the constant 1.06 reveal about the rate of change in this quantity? Okay, so let's go ahead and look at it. Let's remind ourselves whenever we're dealing with these, get a format or a foundation of what things are being derived from. So this is our exponential function. X is in the exponent. Exponential function, the X is in the exponent. All right, so if we see these, if you remind ourselves, this is our zero value. This is our growth or common ratio. So in this case, we got our 1.06, and that's what they're asking us about. What does that mean in this context? Well, in this context, we have our original 100%. We have 100%, and then it's being added by a 6%. So just be careful that it's not 60, it's 6%. So this is 100 and 6% as a percentage number. So what that means is it's growing by 6%. So we're always looking at it in comparison to the 100%. So here's that 1 is the 100%, and then it's being there's an addition of 6%. So sometimes it'll be less than 1, then it's a decrease of however many units it is less than 1. All right, so let's go ahead and answer it the best we can. So that's all we're being asked. Also sort of note the zero value or the starting value is 8,800. All right, so this function is growing. It's growing by 6%. It's greater than 1 exponentially at a rate of 6%. Notice it's in percentages already. And then in this case, we have to look at the original problem. It's in a context of over hours. So then that's the unit of growth. So it's every hour. Okay, let's see how we did. Okay, then let's just analyze. It's always good to look at what their solution looks like. Is greater than 1, so that's our growth rate. So they're subtracting 1. I just kind of look at it as how much more than 1 it is. It's 0.06 more than 1. A lot of these you can just look at straight away. If you need to type it in your calculator, then it just takes a little bit of practice, but that should be pretty straightforward. The units are in hours. That was in the problem. And the exponent is t. That's our time that's given to us. All right. And then they're just kind of going over it. It's growing. Yep. And we're good. Let's go ahead and look at, see if the next one's any different. All right, the function is this right here. Okay, represents the change in quantity over t days. All right, what does the constant 0.9 reveal about the rate of change of the quantity? So let's go ahead and do our best and attack it. All right, notice that we got a 24t up here, so the growth is being multiplied by 24, so it looks like it could even be in terms of hours since we have that 24 right here. But this is what I was talking about. This is less than 1, so compared to our 1, so in this case, our b is, let's y equals ab to the x. There's our formats in case we forget. And then so our b is equal to 0.997. All right, so let's just go ahead and subtract that from the original 1 to see how much it's decreasing by. All right, so we got 1 minus 0.997 is equal to 0.003. So this is so compared to the original, so it's 1 minus 0.997 is equal to 0.003. Now, what is this as a percent? So in this case, I wouldn't recommend doing it in your head. Just go ahead and do it mathematically. Percent means the decimal moves two places. So in this case, it's moving 1, 2. So as a percent, this is equal to All right, 0.3. So this is what it would be as a percent, and this is decrease because we are less than 1. All right, so in the context, I didn't read the problem very well on this one, but that's okay. The function f of t, the growth starts at 870. We have a decrease of 0.3% every 24 days. T is days, so every 24 times. So if you had 1 day, that would be to the 24th power right here. So in this case, that looks like it would be like hours because there's 24 hours in a day. So just kind of making that link, even though they didn't say it. Represents the change in quantity over t days. What does the constant 0.997 reveal about the rate of change of this quantity? Okay, so let's go ahead and just fill in our answers the best we can. This is decaying. Decay is the opposite of growth for exponential functions. So it's getting smaller and smaller, decay. Exponentially at a rate of 0.3% every, and in this case, it's in the context of days. So let's just go ahead and over t days. So it would be as the exponent. So for example, when you have 1 day, it would grow by that 1 times 24. So it looks like every hour in this context. So like I said, that 24t, 1 day, t is days. So if t is 1, it'd be 1 times 24. So that's a growth. That's a growth of 24 every time we have a day. So I'm going to go ahead and say hours in this case because of that 24 right there. See how we did. Yeah, so that 24 definitely affected it. You can't just dive right in to what their input or output is. We have to look at it in terms of the context. So let's go ahead and just analyze what they have here. Yep, everything is less than 1. That's decay. Decay, we had to find it, so subtracting it from 1. Don't guess on that. 0.3, we had to do the math. Unit is t days, so the exponent is 24t. They're talking about reciprocal, so they're just kind of showing it's divided by. How would you look at this as a single unit? So you'd have to divide it by 24 to get t by itself. And 1 over 24, the time of frame is 1/24 of a day. In this case, that would be equivalent to 1 hour. So it just kind of links to that 24. So I just kind of did it through my insight. And they're doing it mathematically and breaking it down. And decaying, yep, everything looks good. See if the next one's any different. T days, and notice t is being divided by 365. Let me get all my other stuff out of the way. So in this context, we got decay. So looking at it, we got our initial value, 2,400. We got decay. In this case, it would be a 6% decay because this one's a little easier to do from the 1. And then t, or your exponent, is being divided by 365. So in this case, if you were kind of solving for t, you would have to multiply by 365, and that'd give you your t of days times 365. So how is 365 and days related? That would be a year. So this function is decay at a rate of 6% is the decrease every, in this case, every year because of how it is related to the exponent, and then every year. Okay.